Hello, Year 4. It's Mrs. Evans here. I hope you're all safe and well. Have you seen our new topic igniter video? Our new topic is so exciting and I can't wait to see the work that you complete at home. I'm going to teach you your maths lesson today, and I'd like to say well done to all of those children who have been logging on to TT Rockstars at home. I'm going to give a shout out to the leaders of each class at the end of the lesson. Today we're going to learn about factors. You'll need a pencil and some paper, so if you need a moment to get yourselves organised, pause the video now and I'll join you in a moment. Here is your starter activity to recap some mental maths. Pause the video and we'll look at the answers together. How did you get on with that? Let's have a look at the first part. So it asks us to use the numbers 2, 12 and 24 to complete the fact family. Well, we can see that 2 times 12 is 24, but we also know that 12 times 2 is 24. And if we know that, we can work out that 24 divided by 12 is 2, and that 24 divided by 2 is 12. Let's have a look at the next section. You'll notice that these all total 18. Can you see why they total 18? We're going to look at that a little bit further in today's lesson. And double 28, well, we could double the 20 and double the 8 and add them together, or we could round the 28 up to 30 and double the 30, which would be 60. But because we've added on an extra 4, we'd need to subtract that 4, and so that would make 56. In today's lesson, we're going to be learning about factors, and our learning objective is to recognise factor pairs. Well, a factor pair is a set of two numbers that we multiply to get a product. We'll look at those words later on in the lesson. But what's the big picture? How can this help us? Well, knowing factor pairs helps us with our multiplication and division. And some of the key vocabulary that we will be using in this lesson will be factor, factor pairs, product, multiply, and divide. We're going to look at a my turn part of the lesson now, and we're going to focus on some of that key vocabulary that we talked about. So a factor is a number that multiplies another number to make a product. So here on the screen we can see that a factor times a factor equals a product, and we've got an example here. So 5 times 4 is 20, so 5 is a factor of 20 and 4 is a factor of 20, and 20 is the product. So 5 and 4 are factors of 20. You can also work out factors using division. So a factor is a number that will divide equally into a number. So we can use division as well as multiplication to help us with factors. And here's another example. So 20 divided by 5 equals 4. And we can see that 5 and 4 here are factors of 20. So again, 5 and 4 are factors of 20. So we're going to find out more about factors, and here we're going to look at the number 6. So here is an array, and this shows one lot of 6. We can show that in multiplication as 1 times 6. 1 times 6 equals 6. But the number 6 here has been made up of one row of 6, one lot of 6. And so the factor pairs of 6 are 1 and 6. Here we can see an array that has been made with 2 rows. So we had 1 row previously, one lot of 6. We've got 2 rows now, and we've got 2 lots of 3. We can write that as a multiplication. 2 times 3 equals 6. But this gives us the factor pairs. The factor pairs of 6 are also 2 and 3. So we found 1 and 6, and now we found 2 and 3. In the first slide, I found 1 row using 6 counters. In the second slide, I found 2 rows. And this slide, I can make 3 rows. 1, 2, 3 rows. And this would show 3 times 2 is 6. 3 lots of 2. So the factor pairs of 6 are also 3 and 2. However, if we think about what we've just found, we've already found a 3 and a 2. And so we would call that a repeat. And so actually the factor pairs of 6 would simply be 1 and 6 and 2 and 3. Because when we look at this, if I turn that array round, that is the same as the array here. So we've used 3 and 2 already. So we can say that there are 4 factors of 6, and there are 2 factor pairs, because we know a pair is 2. So 1 and 6 and 2 and 3. So here we're going to look at finding factor pairs of 24. Well, every whole number has a factor of 1, because 1 will divide into every whole number. So I'm going to start with one row of 24. And so I know that one lot of 24 is 24. Well, 24 can be divided by 1 24 times. So let's have a little look at this array. I can see that that one row shows 1 and 24. So straight away I found 2 factors, and I found a pair, 1 and 24. Can I split those 24 counters into 2 equal rows? Well, actually, yes, I can, because I know that 24 can be divided by 2. So if we have a look at this picture, we can see that 24 counters has been split into 2 equal rows. And so I've got 2 rows, but this time I've got 12 on each row. And so I've now found another 2 factors. I found 2, because we've got 2 rows, and I've got 12 in each row. So my pair now is 2 and 12. Can we make 3 equal rows out of 24? I'm going to use my division now and just have a little think. Can I divide 24 by 3? Yes, I can. So I can now make 3 rows using 24 counters. As we go through the chilies, if you want to try chili 1, it might be if you've got some buttons or some little counters or even pasta shapes or anything like that, you can have a go at making arrays with some little objects at home to help you with this. So I've made 3 rows now, and this time we've got 8 in each row. So I've found 2 more factors, 3 and 8, and I've found a factor pair, because a pair is we know is 2. So I've got 3 and 8 as another factor pair. Can I make 4 equal rows using 24 counters? I can, because I know that 24 will divide by 4. 24 is a multiple of 4. Let's see what that picture looks like. There we go. I've got 4 rows now. This time I've got 6 in each row, because I know that 4 times 6 is 24. So 4 and 6 they are factors of 24, and my factor pair is 4 and 6 because they go together. Can I make 5 equal rows? I'm not sure that 24 divides by 5. When I do my 5 times table, I can't recall 24 being in there. So I'm going to have a little go at that. Now, actually, that doesn't work, does it? Because although I've got 4 equal rows here, my 5th row's only got 4 counters, and they're not equal. So that doesn't work. 5 doesn't multiply by anything to make 24. It's not in that times table, so that doesn't work. So I can't use 5. But can I use 6? Can I make 6 equal rows? Well, actually, yes, I can. However, I've already used those 2 numbers, so we've got to a repeat here. I've already used 4 and 6, and here we've just got 6 and 4. And once I've got to a repeat, I know I've found them all. So when we're talking about justifying or proving, and that's something that Chili 3s might be doing later on in the lesson, then we can say that, well, I know I found them all because I found my repeat here. Okay, when we're looking at factor pairs, it's a good idea to write a list. And I'm going to look at the next slide now, and I want you to help me out here. We're going to look at an our turn bit of the lesson. So to find factors of 24, we could write a list of those numbers. And I can start with 1, because when we start with 1, we know that 1 is always a factor of a number. And we can try and work through in an order. So what do you think goes with 1 to make 24? I'd like you to have a go and see if you can work out the pair that is underneath the yellow rectangle. So pause the video and we'll have a little look together in just a moment. How did you get on with that? Let's have a look together. So we know that 1 would go with 24 because 1 times 24 is 24. Or we could find 24 lots of 1 in 24. Can you work out what 2 would match with? How many 2's would go into 24? Yes, that's right, it's 12. And we know that 2 times 12 is 24. What do you think 3 would match with? What's the pair to go with 3? 3 times something. Or how many 3's in 24 if you were to use your division? Yes, well done. That's 8. 3 times 8 is 24. And now 4, we can see, would match with 6. And so the factor pairs of 24 would be these. These are all of the factors of 24. So now we know that writing a list is a good idea, and we know that starting at 1 is a good idea, and it gives us a method or a system. Can you find the other factor pairs here for 18? So I've helped you out by starting with 1, and I know that 1 times 18 is 18. Could you make a factor pair using 2 or 3 or 4 or 5? And then can you keep going until you find a repeat? Pause the video, have a go, and we'll reveal the answers in just a moment. How did you get on with that? Shall we have a look together? So we know 1 and 18 go together. 1 times 18 is 18. What about 2? Can you think of a number that goes with 2 to make 18? Yes, that's right, it's 9. 2 lots of 9. 2 times 9, or 9 times 2. Let's have a little look at 3. Will 3 go into 18? Is 18 part of the 3 times table? Yes, that's right. 3 times 6 is 18. What about 4? Did we find 4? No, 4 isn't part of, 18 isn't part of the 4 times table. 5? No, neither is 5. 6? Oh yes, 6 is part of the, 6 and 18 will go together because 18 is part of the 6 times table. But that's where we've got our repeat, because 6 times 3 is 18, and we've already found 3 times 6. So that's where we get to our repeat. And once we found a repeat, we know we found them all. So we know that the factor pairs of 18 would be 1 and 18, 2 and 9, and 3 and 6. So we've talked about factor pairs, and we talked about factors. So a factor is simply just one number that will divide into that number, but the factor pair are the 2 numbers that would go together, such as 3 and 6 for 18 that we just looked at. What about this number then? What do you notice that might be different about 25? So what factors does 25 have? Pause the video and see if you can work out which 2 multiplications would lie underneath the blue rectangles. So can you work out 2 multiplications that will total 25, which will give you factors of 25? So what do you think? Well, we know that we can always start with 1, because 1 is always a factor of every whole number. And that's the easy one, so let's get it out the way. So 1 times 25 is 25, so that's 1 that we've done. 2, does 2 go into 25? No. 3? No. 4? No. 5? Oh yes, 5 goes into 25, and actually I know that 5 lots of 5 makes 25. But what do you notice about that? We talked about the factor pairs, but actually 5 is the same number here. So the factors of 25 are 1, 5 and 25. Because if you wrote 5 again, because we've got 5 and 5 here, it's just the same number. So we've got a factor pair here, and then here we've got a pair, but if we wrote a list of factors, we just include 1, 5. So we could say the factors of 25 are 1, 5 and 25. So if we can find all the factor pairs for a number, we've found all the factors. And finding pairs helps because we know our multiplication tables, and we can help to work out 2 numbers that will multiply together to make that number. And then we've got something like 5 times 5. We would just take that one number as the factor. Okay, so it's a your turn part of the lesson now. So based on everything we've done so far, can you find the factors for 12. So see if you can work them out as pairs, because that helps. And we know here that we can start with 1, because every number, every whole number, has 1 as a factor. And when you get to a repeat, you know you've found them all. So see if you can write a list and see if you can have a go at finding the factor pairs for 12. Pause the video and we'll have a look at the answers together in a moment. How did you get on with that, Year 4? Let's have a look at the answers together. Well, we know that 12 would go with 1. 1 times 12 is 12. 2 times 6 would be 12. So 2 and 6 are factors. They're a pair because they multiplied together. And then we've got 3 and 4. And then if you carried on to 4, yes, 4 will go into 12, but it will go into 12 3 times. So you'd have a repeat. So we don't bother writing that because you've just used those numbers again. So that's where we'd stop, and we know we've found them all. So 12 has 6 factors and it's got 3 pairs. 1, 2, 3. These are factor bugs. So we've just looked at factor pairs for 12, and they're a fun way to list factors. So I've drawn a little bug there and written my product in the middle. So 12's there, and I've written the factors on the outside on the little legs. So I've got 1 and 12, started with 1 because that's the easy way of starting, because we know every number has 1 as a factor. And then I've moved on and I've written the factors on the legs. Now, of course, depending on the type of number you're working with will depend on the amount of legs that your bug will have. So here we've got some pictures, and it's a fun way to list factors, and we're going to maybe use that in the rest of the lesson if you would like to. So your chilies. So chili 1, maybe you might need some support with this, maybe from a grown-up, or you might want to use some practical resources or pictures. So if you've got some counters, buttons, pasta shells or something like that to help you to make arrays, then that might be a good idea. Or you could draw some pictures. So you could draw some rows, just like I did earlier. So maybe go back in the video and have a little look at the arrays, the pictures of the counters, and see if that could help you with your learning. Chili 2, I want you to find factor pairs, but explain how you've worked them out. So can you talk to a grown-up or somebody to talk about how you've actually worked those out? And Chili 3, write all the factor pairs for given numbers, but justify how you know you've found all the factor pairs. How do you know that you've found all of them? What is it that you could prove to say, I know that I've got to the end of the line and I know there aren't any more? So your activity now is to find factor pairs for these numbers. So you might want to draw a factor bug, or you might just want to write a list. So you can choose how to record your work, but see if you can find factors for the numbers 10, 15, 20 and 30. And if you pair the numbers up together, that possibly will help you. And when you've finished, if you want to extend your learning, you might like to choose your own numbers. How far could you go with this? So pause the video and have a go and join me when you're ready to look at the answers together. How did you get on with that? Shall we have a little look now through the check part of the lesson and see how you've got on? Well, the first one was 10, and we found that there are 4 factors here. So we've got 1, 2, 5 and 10. If you wrote them as pairs, you will have written them as 1 and 10 and 2 and 5. The factor pairs for 15 are 1, 3, 5 and 15. And if you've written them as pairs, 1 and 15 would go together because 1 times 15 is 15, and 3 and 5 would go together because 3 times 5 is 15. Let's have a look at the next one. So 20 has a few more factors, doesn't it? We've got 1, 2, 4, 5, 10 and 20. If you've written them as pairs, you would have written 1 and 20, 2 and 10 and 4 and 5, because those are the numbers that multiply together to make that product. And finally 30, we've got 1, 2, 3, 5, 6, 10, 15 and 30. Wow, there's a lot there, isn't there? Let's have a look. If you've written them as pairs, 1 and 30 would go together, 2 and 15 would go together because 2 times 15 is 30, 3 and 10, 3 lots of 10, and 5 and 6 because 5 times 6 is 30. Well done, Year 4. we're going to have a little look now at a challenge that you might like to do to extend your learning if you found that you've enjoyed your factor pairs lesson and you'd like to take this a little bit further. So let's have a look at this. Tommy says the greater the number, the more factors it will have. So if you've got a bigger number, does that automatically mean that it will have more factors? So is Tommy correct? What do you think? Pause the video. Have a go with a few numbers, just take some numbers and see if he's right. If the number is bigger, does it automatically have more factors? See if you can prove your answer by recording some ideas. And I'll join you in a moment to see how you've got on. How did you get on with that? Yeah, well, Tommy is incorrect, isn't he? And I've put 2 examples here, but I'm sure you've found others. So 15 has 4 factors. 1, 3, 5 and 15. We found that one earlier, didn't we? But 17, which is greater than 15, only has 2 factors. It has 1 and 17. So Tommy isn't right because 17 is greater than 15 and yet it has less factors. What other ideas have you found? Maybe you'd like to email them into the Year 4 email address and we'd love to have a look at them. So this is the part of the lesson where we'd like to give a shout out to those children who have been on TT Rockstars. So well done everybody who has been working on TT Rockstars at home. These children are at the top of the leaderboard and this is at the time of filming on the 6th of January. So well done to Alice P in 4B, Polly P in 4M, Tyler W in 4EP and Liam C in 4S. Well done everybody. Stay safe, take care, and I'll see you soon. Bye.